Okay, so good morning all. Today's practical is drawing the chemical structure and property calculation by using ChemSketch tool and some online web servers for calculation of the property. Firstly, the structure drawing tool which we are going to use is ChemSketch. You can easily draw the structure on this particular software, and this particular software is open for student. You have to write ACD ChemSketch in Google. It will be like this will be the first link, free chemical drawing software for students. So you have to go to this particular link. Once you are going to the dashboard of this particular link, so you will get a tab with the name of download ChemSketch freeware. Okay, you can utilize this particular. Here you have to write your first name, second, last name, email ID, academic institution, country, and you have to accept the terms and click on download. So this will be the download link of this particular software is going to be sent to you on your Gmail account, yeah, any other account of which you have entered here. This is the dashboard of ChemSketch software. In this particular dashboard, there are few tabs. First is the left panel, which is dedicated to the elemental panel. As you can see, many elements are directly highlighted. If you want any other element which are not mentioned in this particular tab, you can directly press this particular icon so that the complete your periodic table is visualized. The second one, the right panel. So in the right panel, what we are seeing it is like ring systems like cyclobutane, benzene, cyclohexane, cyclopentane. Other ring systems, common ring systems are present. If you are using this particular icon, so there can be more attachments, amino acids which can be used. The top panel is basically used for your saving, cut, draw, delete. This particular tab is going to be utilized for generating the name of the structure. When you will this particular tab is going to be used for cleaning and optimizing the structure as per the requirement of our bond length. Okay, so just we will demonstrate the structure drawing of ciprofloxacin. So as we are aware, the ciprofloxacin is nothing but a quinolone derivative. So firstly, the benzene ring is going to be drawn. In this particular case, what we are doing, we are using the click and drop option. I have clicked, like I have to use this cyclohexane. I have clicked it, I have left the mouse panel, and I am just dropping. If I am substituting on a particular carbon, it is going to be a branching. If I am placing it on the arm, so it is getting converted into a fuse system. Next, if I have to substitute nitrogen, so nitrogen will be just click and drop. Now I have to convert the single bond into double bond, so I will just press on it, so it will be getting converted into this double bond. If I repress it, so again the triple bond appears. Again all the bonds are lost, and as I want the double bond, so it will be presented. For the ciprofloxacin structure, we need the oxygen, so oxygen is used. Now I am just clicking it and dragging it so that OH bond has been created. Now that I wish to convert this OH into quinone, that is ketone moiety. So I will just click this. Okay, once I have clicked it, so it will be changing into your ketone. Further substitutions, what we want in this particular case is carboxylic acid, which will be present at this position. Second, whether it is second or whether it is third. So what we will do, we will count from the nitrogen 1, 2, 3. So this is the position for carboxylic acid. If I wish, I have to draw this carboxylic acid manually. So how I can do that? I will just press on this carbon, I will drag it, I will again create a structure. I will use the oxygen for substituting in this place. So this can again create the carboxylic acid structure, or I can use directly it is from the right panel. Apart from that, fluorine is going to be used. Fluorine will be present at this particular carbon position. Piperazine, it is not ciprofloxacin is nothing but piperazine substituent. So I am just placing it. So you can see if I am not pressed on that particular carbon, so it will be isolated. The ring system will be isolated. So what I have to do, I have to just place my cursor on the carbon atom on which substitution I am desiring for. Nitrogen, this is nitrogen. Okay, now the complete structure of ciprofloxacin has been prepared. I will use this particular icon. I will select the complete molecule and I will clean the structure first. Now the orientation has been prepared. One thing is pending, that is cyclopropane. Now there are few options, like if I am selecting any cyclopropane from this particular panel, I will recreate that cyclopropane by using the bond formula. So I have used like this. Again I am dragging, again I am dragging, and I am now joining it. So the complete structure has been prepared. As selecting the complete molecule, cleaning the structure, this is the ciprofloxacin present. Okay. Now, when we are selecting this particular molecule again, so what we find, I wish to calculate the derive the IUPAC name of this particular molecule. So I will, as I have told earlier, so I will use this particular button. So it will generate the name, IUPAC name of that particular molecule. So you can see the complete name has been arrived. Okay. If you wish to convert this molecule into SMILES, SMILES is nothing but, this is a 2D representation of the structure. SMILES is the single 1D representation of any structure. So I will select the structure first, go to the tools, generate, and SMILES notation. Okay, so this is the case. This is the SMILE notation. This is a linear representation of any structure. I will use this SMILE notation in further softwares to calculate the property also. So I am just selecting it and copying it. Okay. If I wish to calculate, the second practical is to calculate the properties. Okay. So we can also calculate the properties by using the ChemSketch software. I will select the structure again, go to the tools, go to generate, calculate. After going to calculate, I will select the all property. So what we find, this all property has been calculated. This will be your practical key. You can utilize this these particular results and use ChemSketch itself to calculate the property. So you can see molecular formula, formula weight, composition, molar refractivity, molar volume, index of refraction, surface tension has been reflected. Now I will use another softwares to learn more about the structure, that is property. I will calculate more properties. So I will use one software with the name of Swiss ADME. Okay, it is an open source software. You have to type Swiss ADME in Google. Once you have typed it, you will go to this particular tab. So what comes here is, this is particular the panel of your Swiss ADME. I have copied that SMILES, so I am going to paste it. Okay, either you can just draw the structure here itself, press this red button so that it will get converted into SMILE. Both the things can be done. I will use the run option. So when I am using the run option, what will happen? The complete information about that molecule which we have entered is going to be generated. You can see. Okay, so it is divided into your perspective will be more focused on physicochemical property, but apart from that, other properties like physicochemical properties calculated. Lipophilicity, you are aware about कि lipophilicity will play an important role in the bioactivity. Third one is water solubility, again one of the very important perspective. Log S will be calculated. Pharmacokinetics, or just predictive pharmacokinetic data will be available, whether the drug is going to cross the blood-brain barrier, where it is going to be absorbed in the GI or not. So you can calculate this. The drug likeliness property, you have to also calculate this in your practical domain. Lipinski rule. So what is Lipinski rule? So Lipinski rule of 5, or it is also known as Pfizer rule. Okay. So in this particular case, what we are saying, as per the Lipinski rule, molecular weight should be less than 500. LogP should be less than 4.15. Hydrogen bond donor and hydrogen bond acceptors should be in ideal number like 5 and 10. And last one is your rotatable bonds should be in the ideal number. Apart from Lipinski rule, there are many other rules which are also responsible for drug likeliness property calculation. Okay, like Gaussian rule, Weber rule, Eigen rule, Muge rule, and bioavailability score. So you can utilize more about that. The last but not the least is medicinal chemistry property, like Payne's alert. What do you understand by Payne's? So it is the pan-assay interference of the structure. In this particular case, you will be using synthetic accessibility. The more the synthetic accessibility is, the more easier the structure is to synthesize by. Okay, if it is like 1, 2, 3, less than 5, so it can be easily synthesized. If it is 10, so it is tough to synthesize. So again, this particular data can be utilized for the calculation. Okay, in this particular case, all the property can be downloaded in the form of CSV, that is Excel also. Okay, either you can just take a screenshot of this particular data and stick it right away in your journals. Apart from that, in this particular case, the software is not capable of giving us the information about toxicity. What do you mean by toxicity? So I will utilize a new software with the name of Protox. Again, this is free software. Protox, prediction of toxicity of chemicals. So in this particular case, just I will use prediction, like toxicity prediction I will go. Okay, now already the template drug is there. I will use the smiles that I have copied. Okay, so it will generate again. Okay, again the structure of ciprofloxacin has been generated. Okay, now this is the data. Only toxicity cannot be calculated. There are many other informations that can also be calculated by this particular software. So I am selecting all. Okay. In this particular case, organ toxicity alert, like carcinogenicity, immunogenicity, mutagenicity, nuclear receptors, stress receptor pathway, molecular initiating events, and metabolism is also calculated. So I'm selecting all, and I'm just clicking to start toxicity prediction. So what I end up with, this is the range. As you can find, average similarity is 100% because this is a marketed drug. If you are going to utilize any new NCE, that is new molecule, so you can get this average similarity in different perspective. It may be like 50%, 20% as per your alert. Apart from that, the LD50 value is calculated as 2000 mg per kg. What do you understand by this LD50 value? This is the lethal dose at which the 50% of the animals may have died. Okay, so this is also one of the very important data which is utilized for calculation of dose. As per OECD guidelines, 1/10 of this particular LD50 is your biological dose. Okay, as per OECD guidelines, 1/10 of this LD50 is your biological dose. So ciprofloxacin biological dose may start from 200 mg per kg. So this is a ciprofloxacin, but you can also search for new molecules also, and that too in free. The range you can see, if it is green, okay, you can see the range class 4. So it is yellow, red, red to orange, yellow and green. If it is 6, so toxicity is very less, toxicity is there. But if it is yellow or red, so you can consider, so it may be toxic to the body. Other data you can see, organ toxicity, whether it is active or not, what is the probability score. You can download it in the form of PDF or Excel or CSV format also. Okay, so the radar chart of all the data can be generated. Okay, this is a cumulative form. So we utilize two softwares, which ChemSketch for drawing, second one SwissADME for calculation of property, next was Protox for toxicity. One of the software is PKCSM. It is a cumulative software. It can calculate everything. Okay, this is basically responsible for calculation of the pharmacokinetic information. Okay, so you will go to the PKCSM. Okay, again I am having that smile. So now you can understand what is the importance of the smile. Once I have converted the structure into smile, so I can directly proceed forward. So in this particular case, I can selectively calculate whether I have to calculate adsorption, distribution, metabolism, excretion, or toxicity, or I can just go for ADMET, all properties. Okay, so by utilizing all properties, so all the properties will be calculated, and the values will be reflecting. So you can see the values are reflecting. Now what you find many times it is happening, many softwares have the contradiction with the earlier values also. Okay, why? Because it is like one software is working on a particular database, other one will work on another database. So it is recommended, these are all the only predicted values. Okay, these are not the actual values. So the dry lab work should be accompanied with the wet lab work to assure that better drug design process has been carried out. Understood? So just a revision, what it is: firstly it is chem sketch, we drew the structure, we calculated the property, we converted the structure into the smile notation. Okay, after that, once the smile was converted, I utilized the Swiss ADME to calculate the properties. I utilized Protox separately to calculate the toxicity of the that particular molecule, and cumulatively we use the PKCSM data for calculating all the data in a single platform. And this is one of the best one. Why? Because we can actually download it in different form also. You can calculate and download it in PDF. So numerical data, Excel data is utilized. Understood? Okay. So please replicate it on several PCs and try to